Okay, today's video is on combining like terms. Please make sure that you have your distributive packet with you. You will need it to take notes. You will also need your journal because you will need to take some notes in your journal. As we go through the video, pause it whenever needed so that you can stay caught up with the notes. Okay, so go ahead and open up your journal. We're going to talk again about the parts of an algebraic expression. We've already talked about some of these parts when we did our intro to algebra, but now we're going to talk a little bit more about the terms and what makes up the expression itself. So a term. In your journal, go ahead and write this down. Terms are the parts of the expression that are separated by a plus or a minus sign. Now these plus and minus signs, they're actually the signs of the terms that are to the right of it. So for example, in this expression 12 plus 3y squared plus 4x plus 2y squared plus 4, you can look at this as the terms being separated by the plus and minus signs. So when you look at this, 12 is a term, 3y squared is a term, 4x is a term, 2y squared is a term, and 4 is another term. Or the best way really to think about it is that the sign goes with the term behind it. So this is a term, a positive 3y squared, a positive 4x, a positive 2y squared, a positive 4. And then of course this first 12 is a term, and since there is no minus sign in front of it, it's automatically a positive. So these are the terms of this expression. A lot of times it's helpful to know how many terms are in an expression so you can count them. There's 1, 2, 3, 4, 5 terms. Let's do another example. If I have 6x minus 42 plus 3y minus 6 plus 8x. I can go and I can circle each term. Terms can be a variable with its coefficient. So this 6x would be a term. This negative 42 would be a term, and that's called what? When it's just a number, it's a constant. Then we have a positive 3y, a negative 6, that's another constant, and a positive 8x. So how many terms? 1, 2, 3, 4. This one also has 5 terms. Excuse me. We've already talked about coefficients. Go ahead and write it down in your notes. Coefficients are numbers that are multiplied by at least one variable. So 12 is not a coefficient because there is no variable. 3 is a coefficient because it's multiplying by y squared. Remember, it tells you the number of groups of the variable that you want. We want 3 groups of y squared. 4 is a coefficient. We want 4 groups of x. 2y squared is another coefficient. We want 2 groups of y squared. And 4 is not a coefficient. There is no variable. It's just a number, so it's just a constant. So we can go and we can circle. Well, maybe not, because this is actually the same expression that we have up here. Okay, so like terms, this is new. Like terms are terms with the same variable or variables raised to the same powers. So an expression. (3y plus 2y). If I circle them, 3y is a term and positive 2y is a term. Do they have the same variable? Yes, they both have a y. Are they raised to the same power? Yes, they're both to the power of 1. So these are like terms. If I have 6 plus 2x squared plus 3y minus 8 plus 4x squared. We're going to go and circle all of our terms. So the first one is a constant, it's just a number, 6. Our second term is a positive 2x squared. Then we have a positive 3y, a negative 8, there's another constant, and a positive 4x squared. So if you want to look for the like terms, terms have the same variable raised to the same power. So our first variable term is x squared. Do we have any other terms that have an x squared? This one is a y, this one is an x squared. So these two are like terms. They have the same variable x and they are raised to the same power. Their x's are both squared. So they are like terms. Then we have a y. Do we have any other y variables? No, we do not. So this one is a term, but that does not have any like terms. Now let's talk about the constants. Okay, constants are technically not terms, like terms, but we kind of consider them, even though they don't have a variable. When they're just constants, we need to note that we have two of the just constant numbers, because those can be added together, can be combined to make a simplified expression. And that's kind of what we do with like terms. When an expression contains like terms, you can use properties to combine like terms into a single term. So looking at our two constants, we can combine them, 6 and a negative 8. The signs are different, subtract, and you get a negative 2. Then our next like terms are our x squared terms. We have positive 2x squareds and positive 4x squareds. To combine them, we add their coefficients. 2 and plus 4 makes 6. Positive 6, and it's x squared. The variable and the power stay the same. And then our last term was the positive 3y. And this was the only term that had a y in it. So we just keep it the same, positive 3y. So we went from an expression that had 1, 2, 3, 4, 5 terms to an expression that has 3 terms. So we've simplified the expression by combining like terms. And this is important when you do algebra, because you don't want to work with this long expression here. Just like with fractions, working with simplified fractions is easier. Working with simplified expressions is also easier. So let's do a few examples. Excuse me. Go ahead and do these in your journal. First one is 6x squared minus 4y squared. First thing you always want to do when you combine like terms is you want to circle like terms or put some kind of shape around it. So on our first term we have 6y squared. I'm going to circle it. Any other x squareds I have, I'm also going to circle. And if you look, the next term, negative 4x squared, is also an x squared. So we have the same variable, they're both x's, and they're both squared. They're both to the same power. So I can circle this one. These are our like terms. Now we can combine them. We can add them together by adding their coefficients. A positive 6 and a negative 4. Different signs, so you subtract. 6 minus 4 is 2. And then the variable and the exponent stay the same, x squared. So this two-term expression can be combined to one term. Okay, second example, 3a plus 2b plus 5a. I'm going to start with my first term and circle it. You need to do this as well, 3a. And I'm going to go through, do I have any other a's? Yes, I have this 5a. Are they to the same exponent, same power? They're both to a power of 1. It's that invisible 1 again. So yes, this is a like term, so I'm going to circle it. My next term is a b. So I'm going to put a different shape around it, and I'm going to include the sign in front of it, a positive 2b. So I used a square. Do I have any other b terms? No, I'm out of terms. So now I can combine the terms that have the same shape around it. So I can combine my a's by combining their coefficients. 3 positive 3a's, positive 5a's make positive 8a's. I did not have any other terms that had b's, so I just keep this the same, plus 2b. So again, we went from a 3-term expression down to a 2-term. And our last example, y plus 11x minus 7x plus 7y. So I'm going to start with my y. And remember, the coefficient is an invisible 1 because there's one y. Do I have any other y's? Yes. I have a 7y. It's a positive 7y. So I'm going to keep the same shape, a circle. Now I go on, my next variable is an x. So I'm going to put a square around it. Different shape because it is a different variable than the y. Do I have any other x's? I do. I have a negative 7x. If you'll notice, they both have the x variable and both of them are to the power of 1. Now I can combine my like terms. I can combine my y's. This is the invisible 1 coefficient and a positive 7 coefficient. So 1 plus 7 make 8 y's. And then I can combine my x's. Combine their coefficients, a positive 11, a negative 7. Different signs, I have to subtract, and I get a positive 4x. So this expression went from 4 terms, and it simplified to 2 terms. Much easier to work with. Okay, go ahead and turn to page 4 in your packet, your distributive packet. Turn to page 4. Okay, we're going to practice combining like terms. So in the middle of the page, in these boxes, you have a whole bunch of terms, and you have trees. Okay, each tree you are given a term, and you want to find all of the like terms. So in the first tree, the top left-hand tree, we want to find, this is the y tree. So we want to go through our terms in our boxes, and we want to list all of the terms that are like to the y, all of the y terms. So let's go ahead and do that. If I go through, okay, this first term here, xy, it has a y in it, but it also has an x. Does our tree have an x as well? No, it does not. We want only a y, so we cannot use the xy term. So we keep going. Here's a y. Say negative y, so we're going to write it in our tree, negative y. Keep going. We have 9 y's, so we can add that to our tree. Do you see any other y's? Yes, we have an 11y, so we add that to our tree. Keep going, keep going. We have another 9y. Keep going. Any other y's? Yes, a 3y. Okay, so now we have all of the y's that belong on our tree, and we can combine their coefficients. We're going to simplify all of these y's by combining them together. So this first one, this negative y, it has that invisible 1. So that's a negative 1. Plus 9 makes a positive 8. Plus 3 makes a positive 11. Plus 11 makes a positive 22. Plus 9 makes a positive 31 y's. And that goes in the circle. So what we did for our y tree was we went and we picked all of the y terms from our box. And we wrote them, we placed them in our tree. Then we combined all 5 of these terms to simplify it and make one y term. Okay, you're going to do the same for the x squared tree. You'll notice there's only 3 boxes in the tree, so there are only 3 x squared terms. Can I have, is x the same as x squared? Are these like terms? They do have the same variable, but this one has a square. The power is power of 2. X really is the power of 1. So they do not have the same power, therefore they are not like terms. Okay, so you're looking for the x squared terms. Here's the z. You're looking for all of the terms that have a z. If I have a term that has a yz, are these like terms? Is that the same as a z term? Yes, it has a z, it has the same variable, but this one also has a y. This one does not, so they are not like terms. We're looking for the terms that have only the z variable. And then the lower left-hand tree has an 8. That stands for a constant. The terms that are just numbers. So you'll look through, and all of the terms up here that are just numbers you'll put in your tree. Once you have them all placed in your tree, then you combine all of the like terms for the tree to get one simplified term. So pause the video, go ahead and finish your trees, and then you'll come back and check your answers. Okay, let's see how you did. Let's go to our x squared our x squared tree. If you look, the like terms are x squared, 6x squared, and negative x squared. So if we were to combine their coefficients, the x squared has a positive 1 coefficient. Negative x squared is really a negative 1. So these two cancel out, they make a 0 pair. A positive 1 and a negative 1 make a 0. So that leaves us with 6x squared. So our combined answer would be 6x squared. Coming down to our z tree, we have positive 4z's. We have a positive 2z, so that makes 6. Minus 5z's, so 6 minus 5 is 1. Plus 2z's would make 3z's. And then finally add it to 7z's, and we get a total of 10z's. And for our constants, we have a negative 11 plus a negative 7. Like signs, add them up, you get negative 18, plus a positive 19. Different signs, subtract, it leaves you with 1. Okay, this concludes the first part of the video. You'll need to continue with the video part 2.